All right, guys, are there any questions over the homework assignment so far? I think 7, 8, 9, 10, 11, 12, 13, 14. So we're missing 6. Yeah, 5 are ag. So what we're doing today is operations with polynomial functions. So we're going to be looking at addition, subtraction, and multiplication. We're not going to look at division today. We will look at division tomorrow and Friday. Because there's 2 different ways we can divide polynomial functions. If I were a betting man, I would bet that you're going to like Friday's version of division better than tomorrow's. But we'll see. Because each their own, some like tomorrow's way better, more than Friday's, and some like Friday's better than tomorrow's. So what we're going to look at first is addition. Now there's 2 different ways we can add polynomial functions. One of them is vertical, and the other is horizontal. So vertical, we're talking about up and down. So what we can do first is write the first polynomial expression. So 3x cubed plus 2x squared minus x minus 7. And we can put the other one on bottom underneath it. But whenever we do this, you do need to make sure that you combine or line up the like terms. So we start off with x cubed. I'll put it under the x cubed term. Next one's minus 10x squared, so I'll line it up with the x squared. And the next one we have is plus 8. So I wouldn't want to put it under the minus x. I'll put it under the minus 7. Just so we have them lined up, and they line up nicely. If one of them on top was missing a term, so if it didn't have an x squared term, I would leave a spot there, vacant, just so we could have it line up nicely, especially if the one on bottom has an x squared, but the one on top doesn't. And they are what? We're adding, yes? I put the plus or minus sign, whichever operation we're doing, all the way across. Just as a reminder to myself that we are adding and not subtracting. Or we can add. So we start off with x cubed. So 3x cubed plus x cubed is 4x cubed. The next one we have is 2x squared plus negative 10x squared, which is negative 8x squared. Almost, it would be negative x. Because we don't have any other x terms to combine it with, it's just going to come straight down. Because we were really saying that we have negative x plus 0x. Negative 1 plus 0 is still just negative 1. So we have negative x. And lastly, negative 7 plus 8 is going to be a positive 1. And that's it. Now, unfortunately, we can't type these into a calculator because here x is not an actual number. It's just a variable. So we can't plug them in. Because it needs a value for x, which is unfortunate. There are calculators that could do this, but most of them are banned on any standardized test. So it doesn't help us to learn how to use them if we can't actually use them on a standardized test or use them somewhere else. Questions on this here? The other way we can do is horizontal. 9y cubed plus 3y squared minus 2y plus 1. And we're adding to that negative 5y squared plus y minus 4. So this here is probably the way you're used to adding or subtracting these polynomials. Now, since it's plus and there's nothing in front of either set of parentheses, we can go on and just drop the parentheses. So we have 9y cubed plus 3y squared minus 2y plus 1. And we could say plus, or we can just say minus 5y squared plus y minus 4. Because we could put plus negative 5 or just minus 5. Either one of those is the exact same. questions on this so far? Well, at this point, we could move the like terms next to each other. So put the negative 5y squared next to the 3y squared. Put the plus y and negative 2y by each other. And our plus 1 minus 4. Yes, sir.
So on the second step, we just took off the parentheses. And how do we do the third step?
Third step, I'm just moving them around so the like terms are next to each other. Because now we can see our like terms and which ones we need to combine. Now 9y cubed, we only have that as our y cubed term. That's its only like term. But 3y squared minus 5y squared is negative 2y squared. Negative 2y plus y is negative y. And 1 minus 4 is going to be negative. Okay. Any questions on any of this here so far? Now, realistically, we could have skipped from here to here and just combined the like terms and been done. We don't have to do that step necessarily. Questions on this here? So we'll look at another one with addition vertically. So when we add 2 vertically, we can start off with our first set. So the biggest term is 2x cubed, x squared, minus 3x plus 4. Over, so we have x cubed plus 7x squared minus 2, so we'll line up the like terms. So put our x squared cubed under 2x cubed, our plus 7x squared under the x squared. Since we don't have an x term, we'll move over and put the negative 2 under the 4. We're just lining the like terms up. And then we are going to add. Add straight down. Yes, 2x cubed plus x cubed is 3x cubed.
Plus 8x squared.
Yes, x squared plus 7x squared is going to be plus 8x squared. Because the negative 3x, we don't have anything to add to it, so it just stays negative 3x. And 4 plus negative 2 is going to give us 2. We'll see. Any questions on this so far? And again, we can do horizontal. So we can see here, just to make sure, with addition, if we're adding the 2, it's really not going to make a big difference one way or the other. But subtraction, it does, because we do need the reminder that the second set of parentheses, that negative does have to be distributed through. So for here, really, we could have just left the parentheses off or just dropped them. And combine like terms. Well, negative 4y cubed is going to say that because that's the only term that has y to the third. Now, 2y squared and y squared are like terms, so 2y squared plus y squared is going to be plus 3y squared. Negative y and negative 6y are like terms, so negative y minus 6y is negative 7y. And the last one we have 2 plus 9 is. Now I put the different symbols underneath them because I will do this especially when I'm working some of these here and they get pretty long, as a way to keep track of the like terms. And it also gives me a way where I can look back at it even if it gets twice this length and see, do I have all of my like terms? Do I have all the terms accounted for? Because if I look across and see one of the term without something underneath it, I know I left it out. I didn't actually include it. I overlooked a term. So it's a way to kind of keep track of them. And I always put a different one for each like term, just so I can keep track of which ones go together. Any other questions on addition? We feel comfortable with addition. And addition, horizontal or vertical, I don't think it makes a big difference one way or the other. Subtraction, I feel for some, is a lot easier to do vertical than it is horizontal. It helps, y'all are able to keep track of the signs a little bit better. Now, if we look at the first one here, we have 2x cubed plus 6x squared minus x plus 1. On bottom, we'll line it up. So we'll have 8x cubed minus 3x squared minus 2x plus 9. So I line all of my like terms up, and we're going to subtract. And with this here, again, I put that subtraction in each of the different spots. So we have it all the way across, because especially for this here, it's not too bad, but if we get longer and longer, I have seen it, and I've done it before, where I'll get about halfway to 3/4 of the way through, and for some reason stop subtracting and start adding them together, which will end up giving us the wrong answer. And we can also kind of edit this more or less as we go through it here. Now 2x cubed minus 8x cubed. 2 minus 8 is x cubed. And this next one here is kind of what I was referring to when I said edit. Because our next one is what? 6x squared minus negative 3x squared. So a negative and negative make a, well, I can go in here and say positive. I can turn it into a plus. 6x squared plus 3x squared is going to be plus 9x squared. Because I can go in and easily change the negative and negative, make it a positive so we know what we're working with. The next one, negative x minus negative 2x. Well, here, negative, negative make a positive. Negative x plus 2x is plus x. And lastly, 1 minus 9 is negative 8. And that's it. Questions on this here? We ready for the next one? Next one's horizontal. 3z squared plus z minus 4. And we're subtracting from it 2z squared plus 3z. Now this one here, we do need the parentheses, especially for the second one, because we have to apply that negative to both terms. When we did it vertically, we did apply that negative to everything in the second one. We just didn't specifically write it out because we had that subtraction across every single one. We took it into account. But if we do it horizontal, the first one's not going to change. But the second one, instead of having positive 2z squared, we have negative 2z squared. Instead of positive 3z, we have negative 3z. Questions on this here? Now we can combine like terms. 3z squared minus 2z squared is 1z squared. We have these here. Positive z minus 3z is negative 2z. Next we have minus 4. Yep, because we don't have anything to subtract from it or add to it, so it just stays negative 4. Any other questions on this here? How do we feel with the subtraction? Do we need to see another example of subtraction? We feel good with addition and subtraction. because I put more in here just in case, but if we feel comfortable with it, we'll move on to multiplication. And again, I believe that you pretty much, y'all have done this before. Y'all have added, subtracted terms like this before you did it in Algebra 1, but that's about all you did. Combining like terms, and that's really what it was focused on, combining like terms, adding, subtracting. Multiplication. Now, we can do this horizontal, we can do this vertical. I'm mainly just going to focus on horizontal. In horizontal, all we're doing is the distributive property, multiplying through. So we'll start off with negative x squared. So we'll say negative x squared times x is negative x cubed. Negative x squared times negative 3. Negative and negative make a. And we have 3x squared. Questions on this so far?
So first we multiply the negative x squared to the x.
And to the negative 3.
That's how we got it.
Now we're going to do the same thing with 2x. 2x times x is going to be plus 2x squared. 2x times negative 3 would be negative 6x. And lastly, we do it with the 4. 4 times x is going to be plus 4x, and 4 times negative 3 is negative 12. Now, luckily for this one here, for us here, our x squared terms are right by each other, our x's are right by each other. And normally, especially if we have them both in standard form and none of the terms are missing, and we multiply a polynomial by a binomial, a two-term second one, all the terms will line up. We'll only have one for the first, one for the last. So negative x cubed by itself. But 3x squared plus 2x squared is going to be plus 5x squared. Negative 6x plus 4x is negative 2x minus 12. So you guys have done these before, but you really haven't done too much where we had a trinomial, a three-term, multiplied by a binomial, a two-term, in that kind of way. We go 2 times 3. But with multiplication, does order matter? No. So I could do this as y plus 5 times 3y squared minus 2y plus 2. Or I could put the 3y squared plus, or 3y squared minus 2y plus 2 first. Because we can put them in either order. It doesn't matter. And again, we'll do the same thing here. So this time we're going to multiply by y first. Y times 3y squared is going to be 3y cubed. Y times negative 2y is going to be negative 2y squared. And y times 2 is going to be plus 2y. We'll do the exact same thing with 5. So 5 times 3y squared is going to be plus 15y squared. 5y times negative 2y is, subtract 10y, and 5 times 2 is plus 10. Now this one here, the like terms aren't next to each other, but that's fine, because the first one we're going to have is 3y cubed. Our 2y squared and 15y, so we have negative 2y squared plus 15y squared is plus 13y squared. 2y minus 10y is y. And lastly, we have plus. Questions on this here? It will give you a number. It'll give you a number depending on what y is set to be in the calculator. It has to have a value in the calculators. Questions on any of this here? Now, there are some online programs, especially if you feel like this came out to be something weird. You could type it in and let it do it for you to check to make sure you got it right. But I would at least make sure that y'all know how to do these, because they're not bad, it's just takes a little bit of time to do them. Any other questions on multiplying these together? We ready for the next thing? We want to multiply x minus 1 times x plus 4. One more time. Yes. So really, I'm going to pick two that multiply together. The two that I picked to multiply first really doesn't matter. The one I would avoid is multiplying x minus 1 and x plus 5 first, mainly because how I set it up, they're on two ends. So it'd get a little funky. So I'd either pick the first two or the second two. We can do the first two. So x times x is going to be x squared. X times 4 is going to be plus 4x. We'll do the same thing with negative 1. Negative 1 times x is negative x. And negative 1 times 4 is negative 4. Now, if you wanted to at this point, you could go on and multiply these together. I would wait, mainly because at this point, each of the numbers in the first set of parentheses will give us two different terms. So we were looking at 2, 4, 6, 8 different numbers. But in that first set of parentheses, do we have any like terms? 4x and x. I'm going to go on and combine them. Whenever you multiply two of them together, if there are like terms in that set of parentheses, combine them before we multiply again. Because now we'll only have 6 terms with this next multiplication instead of 8, which isn't too bad. But if instead of having 4 we had 5, that could have been simplified down to 3, so we're looking at 15 or 10 terms instead of 6. So it would get bigger and bigger. So if we can condense them down, let's condense them down. And then we do it again. It would be x cubed. X squared times x would be x cubed. X squared times 5 is plus 5x squared. And then we do the same thing with 3x, which would 3x times x is indeed 3x squared. And 3x times 5 is 15x. And lastly, negative 4 times x is negative 4x, and negative 4 times 5 is negative 20. Combine like terms. So we'd have x cubed. They are next to each other. 8x, 8 cubed plus 8x squared. 15x minus 4x is going to be plus 11x minus 20. And that's it. We can make it quote unquote harder. But is this any harder? No. We're just doing the same thing multiple times. There's more numbers. I could throw in decimals, we could throw in fractions, but it's not changing what we're doing. It's just changing, not changing the step, it's just changing how it looks, how the numbers come out. Which, guys, in some ways it makes it quote unquote harder because we're having numbers to keep track of and more stuff to keep track of and account for. But it doesn't make it actually harder. It just makes more steps. I was just writing that up there. Harder, more numbers, different numbers. Now, the last thing we're looking at is this here, special product patterns. Now, we already had the difference of perfect squares. That's one of the ones I think most of y'all liked with factoring, because if we had x squared minus 9, it's x minus 3 times x plus 3. We could go the other way around, because if they give us x plus 3 times x minus 3, it's just x squared minus 3 squared, which is x squared minus 9. We can go one to the other. And for some, it is faster. And for some, it ends up being about the same, because our square of a binomial are perfect square trinomials. So a plus b squared is the same as a squared plus 2ab plus b squared. So if we plug in the values for a and b, so y and 4, so we're really saying that we have y squared plus 2 times y times 4 plus 4 squared. We can simplify to this here, because y squared is going to be y squared plus, so 2 times 4 times y, 2 times 4 is 8, times y is going to be 8y, plus 4 squared is 16. So we can do that with any of them and get there faster. For most of the squares of a binomial, I'd say you'll end up getting there at about the same pace. The places where this starts becoming useful is when we start getting above powers of 2, so to the third power, a plus b cubed. It gets a little bit faster to get there. And especially when you start looking at to the 6th, 7th, 8th, 9th, multiplying it by itself that many times, these here get to be a little bit faster than to try to multiply it by itself 9 times. Because if we look at this first one here, so we could say it's 4n squared minus y squared. Because this is just following the difference of perfect squares, that a squared minus b squared is a plus b times a minus b. Well, 4n squared, 16n squared minus 25. Now, I'm going to erase that there. If we did multiply it out, 4n times 4n is 16n squared. 4n times negative 5 is negative 20n. 5 times 4n is plus 20n. And 5 times negative 5 is negative 25. These would now the second one, you'll need to 9y minus 2 squared. If we're following along with the method for this here, it's going to go with our ab minus a squared minus 2ab plus b squared. Well, a squared, our a in this case is 9y, so 9y squared would be 81y squared. Minus, so 2 times a times b, so 2 times 2 times 9y, 2 times 2 is 4, 4 times 9 is 36, so we'd have negative 36y, plus 2 squared is 4. So this here, and again, I know that was a lot, I just threw a whole bunch of numbers just at you. This here, I feel like there's one way is not faster than the other. Because all we're doing is saying 9y squared minus 2 times 9y plus 2 squared. Well, 9y squared is 81y squared minus 2 times 2 is 4 times 9 is plus 2 squared. Yes. And that should be 81. Mm-hmm. Yeah, no. There's no way 9 squared should get to be a smaller number. Mm-hmm. So that's one way we can apply this here and get there. Now, we're also saying really that 9y squared is just 9y minus 2 times 9y minus 2. 9y times 9y is 81y squared. 9y times negative 2 is negative 18y. Negative 2 times 9y is negative 18y. And negative 2 times 2 is 4. Combine like terms, and we get to the exact same place. So with most of these, especially with multiplying it by itself, squaring it, at this point, especially if you're not fully familiar with how these formulas work out, you're not really saving yourself much time from just multiplying them together than applying the formula. And especially with AB plus 4 cubed. Because we can multiply it by itself 3 times and get to the same place as applying it to the formula. Because again, at this point, I'm not expecting y'all to memorize these formulas and try to apply them every single time. Because at this point, it's just as easy to multiply it by itself 3 times and be done and not have to focus too much on that. The only place that these especially become very helpful is when we start getting to powers of 3 and greater, or we start getting a lot bigger numbers or fractions. Now, Pascal, an actual person, figured out this here, and they call this the Pascal triangle. And what it works out is we have this here, but this triangle, what they also have termed the factor tree, works out very interesting. And if you start out with this tree or kind of triangle of ones, we can build the rest of it. Each new row will always have a set of ones extending out from it on either side. Okay? Now, in the middle, these here come from the previous 2. So 2 and 1 gives us 3. 2 and 1 gives us 3. If we look at the next row, 1 and 3 gives us 4. 3 and 3 gives us 6. 1 and 3 gives us 4. Same thing's true for the next row. And we can extend it out beyond this. Because the next row, well, we'll have our 1, then 6, 15, 20, 15, 6, 1. And those are the factors that go along with when we multiply a binomial by itself a certain number of times. Because if we look over here, 1, 4, 6, 4, 1, 1, 4, 6, 4, 1. So what we're looking at, yeah, so the 6th row, so we're looking at a plus b to the 6. And the way this works out is actually quite interesting, because for a to the 6, so a, our first term, starts off with whatever power we have. So we'd say a to the 6 plus, we would subtract 1, so a to the 5th, plus a to the 4th, plus a to the, oh, I need some space, because we'll have a number in front of it, a to the 3rd, plus then we'll have a squared, plus a, plus, and then a to the 0 is 1. Now the other term, b, because our other one, for a to the 6, well, it starts out at b to the 0. It's going the other way. Instead of going down, it's going to go up. So it starts at b to the 0. Then we would have b to the 1st, b squared, b cubed, b to the 4th, b to the 5th, and then b to the 6th. And really, for whatever terms a and b are, we would plug them into each of those spots and apply the power. Now, as you've seen, there are numbers attached to it, yes? Well, we added that new row, so we'd have 1, 6, 15, 20, 15, 6. And so if we wanted one, all we've got to do is plug in the values of a and b into this, simplify, and we're done. Yes, sir.
This is off topic, but I have to say it, but you know that dude, right? Now he's off in drama.
Yeah.
I noticed that he has 5 fingers.
Yep. This is the picture. Yeah, he's. Huh? Yeah.
Have you seen that one where they go to like the second dimension or whatever? It's like,
Flatland.
Is that the guy that's stupid for everybody else?
Here, no, because Flatland is actually a reference to a book from the 1800s, talking about a two-dimensional world. But that's all we're going to do. Yeah. But Flatland is actually a book that was written